The brothers Wisp. The brothers Wisp, brothers Wisp. The brothers Wisp. The brothers.
You're now listening to Greg, it's the Brothers Wisp. Let's take a ride through space on this mothership. Wireless networking, we talk about equipment and methodology, so sit back and start learning. Lighten up the tower so people...
Hey everybody, this is Tommy with the Brothers Wisp. Today we have a fun episode where we're going to be deep diving into really fun queuing topics. The cake is not a lie is what I wanted to name this, although Dan was already poking holes in my in my naming technique this morning. So over to my left is John Fernandez. Where are you based out of, John?
We're based out of Phoenix, Arizona, but we cover all of Arizona and a few other countries as well. So,
okay. And then, so what will be your user base about these days?
for Arizona or Mexico or
In general.
In general,
Whichever number you like makes you feel the best.
Whichever one's bigger.
well, Arizona is our biggest because that's where we currently live. So we're about hitting 3,000 now.
Okay.
Sitting in a trailer park of another 300 that we're doing right now. So
Cool.
then Mexico, we're about at 5,000. Panama is about 1,000. That's pretty new. Philippines, I'm not even sure because the economy there, we just kind of set up like basically cafes and stuff like that where people go and they pay by the hour.
Yeah, I've experienced that for the first time when I was down in Mexico, and I was like, this is really weird, really cool, interesting idea. And the internet was actually pretty good, but
Yeah.
It was super interesting. So, and then the next ISP I have is Zach Biles down here below me. Hey, Zach. Where are you based out of these days?
Mountain Iron, Minnesota, which is like almost to Canada.
Okay, so you're
way north.
Yeah, so you're with me in having gotten all the smoke from Canada.
Oh yeah, it was pretty thick. We didn't have any issues, but I heard some other people having some link drops during that. So
yeah, there's I guess the really high frequency stuff, people were seeing some significant attenuation to their links. By the way, before I go too much further, I really love the Star Wars posters. Those are awesome. So about how many customers do you have these days?
we're pretty small still, just a couple hundred. So, but growing. So
Well, most WISPs are. That's the best part.
yeah.
All right, and then in order of appearance, I will have Robert over here on the right.
Howdy, my name is Robert Chacon. I'm with Jackrabbit Wireless. We're a small ISP in far west Texas and El Paso, and we also service parts of southern New Mexico.
Okay, and then you also develop Libre QoS or participate in that somehow.
Yeah, so the ISP led to tinkering around in software development and trying our hand at creating a QoE QoE solution. So we created LibreQoS, and that's what we use on our network, and we're trying to get as many ISPs involved as we can.
Cool. And about how many customers do you guys rock?
Currently, we have about 400, but that number is growing. So we started pretty recently, so we're still scaling up, but about 400 at the moment.
Awesome. That's really cool with that user base, and then developing and contributing. That's awesome. Congratulations. All right. And then down here is Dan. You're up in Canada land, aren't you?
Yeah, so we're near Toronto. The smoke started very far from me, so apologize for it, but I didn't do that.
Okay.
But yes, there's been a lot of fires. Yeah, so my history, I owned an ISP a long time ago, back in the dial-up DSL days. Then ended up working for a slightly larger ISP after that, doing network stuff. Eventually, after school, ended up working for a big DPI vendor with all the big tier ones for several years. So got lots and lots of experience with tier ones, and then eventually decided didn't like the tier ones as much and wanted to do stuff with small ISPs. And that's kind of how we ended up building Perceive afterwards. So some of the same problems, but a very different focus and approach than what we were doing kind of in those days. So yeah,
then,
ISPs pretty much forever in some form.
Awesome. All right. So, and then down here on the bottom right, last but far from least, we have Dave Taht, hailing from Nicaragua, if I recall correctly.
Yeah, I'm down here doing research into wave termination along the seacoast here. In other words, surfing and swimming a lot. But I actually am my buffer bloat story started here 15 years ago. And catching up on the state of the art down here is pretty good. I'm a little shy about showing up on video. I'm hoping my audio is good. Yes?
Yeah, you sound pretty good.
All right, so my background is that I helped develop some of the first Wi-Fi APs in '98. And came down here to start what was called a WISP before we had WISPs, and I went under due to the fact my network wouldn't survive the rain. And since dedicated my life to helping invent algorithms and distribute them to this world in the hope that you all do better than I did.
So, well, I've read a lot of your commentary and talk. So, your ISP, you were having lots of issues with connectivity being pretty dynamic, and that killing your links. I guess could you kind of give some clarity and like what made you think that buffer bloat? What told you buffer bloat was a problem?
I didn't figure it out, honestly. Down here, the rainy season is about 2 months long, and I had upgraded my network from wireless G to wireless N. Everybody was happier. And then it started to rain, and the models that I had for how the performance would have degraded were accurate. But all of a sudden, my network would start going down completely. And I didn't track it down until after a fellow by the name of Jim Geddes was getting similar results up in the States. So I had shuttered my doors and said, aha, wait a second. That's what was going wrong. And I still had the routers that I was using. Those were NanoStation M5s, and or maybe they were even M2s. And yeah, I was seeing, you couldn't stream net radio, for example, while doing anything else over these radios at the time. And so I decided that, yeah, that was one of the biggest problems the whole internet had. And we've been working on it ever since.
Okay. So I guess I would be the last one. I've been doing internet for 6-7 years now. Got out of school, needed a job, and talked to my boss, talked to the guy who became my boss. And he had offered me a job back when I was in high school. And I was like, well, it's a few years later, but maybe now the job offer is still available. So, and it was. And so he hired me on as a level 1 tech to install radios on roofs and sit at the bottom of a tower and send him up tools. And that was my first summer working in the ISP industry, is taking pictures of grain elevator legs, because you're just sitting there staring and baking. So we were running actually a lot of Ubiquiti stuff at the time, and I was always looking for like, okay, how could we push more bandwidth? Because the radios would report, oh, we can do 150 megabits per second or 130 megabits per second, and we were selling plans like 4, 6, and 8 megabits per second. It's like, God, well, like, how do we do this? How do we improve things? And I looked at all sorts of crazy projects. There was a short little while where there's distributed internet web browsers, and like your web browser would host your own website, and you could go to other people's websites locally. And it was I was like, oh, maybe it's something here. And I looked at content caching. I looked at all sorts of different like web innovations, like, okay, web 3.0, we can change this, we can make the world better, and I can get better internet for people. And what it really boiled down to was we were paying oodles and oodles of money for fiber out to the middle of nowhere, and that was expensive. And so it was the upstream costs, and then also downstream, we were running 802.11n gear with the Ubiquiti M5 series, and that was, even 7 years ago, that was outdated. And so I was like, okay, how can I improve things? How can I improve things? And upgrades, doing all sorts of different things. And there was always the phone calls of like somebody's using all their internet and their internet was broken. So like PlayStation doing updates or Xbox, those are the worst, especially when you have little plans like that. Like that'll instantly kill it. I one time, because my boss was crazy and left me alone in the CO, I plugged my laptop in because I was like, I have like a 5 gigabyte update. I want to, do this really quick, right off of our head end router. Plug that in, and I killed the internet for all 700 of our customers at the time because my laptop was had really low latency over to Steam's servers, and Steam was like, oh, I can send the whole gig pipe to this guy. And I was like, and NVMe drive, I could take it as fast as the internet could give it to me. And I did realize what the problem was fairly quickly, and I was like, oh, this is very bad. Needs to stop. And I unplugged and had to redo the update. But yeah, so that was my first, like, those were kind of my first experiences, is like, how do I queue bandwidth well? Originally we were using PCQ bandwidth limiters in Mikrotik, which was pretty good, actually. All things considered, we went years on it, and we were able to kind of balance things out. And okay, sometimes we'd get one customer who just always had to stay up, and so we'd go into their router and we would set queuing up inside of their router and be like, okay, if this device has to be on this port, and it has to have this IP address, and it has to, like, if it wants stuff, it should be able to get its bandwidth. But other devices, we would just, like, even still, like the Xbox, everything else would be limited to just below their plan, so there, video calling and whatever could work. And that was sustainable up until about 2020, when the world blew up, and everyone everywhere needed to be able to do video calling from their home all the time. And any, like, I don't know how many routers I did in that summer, setting up. It was just one after another, and I never could keep up with everything. And of course, somebody would move a port, or somebody would, use a different device, and it was just nightmare after nightmare after nightmare. And I really was like, at that time, I had been researching and learning about FQCodal, but it wasn't available for us to implement in our network. But I threatened to quit, actually, if I didn't get a solution, because we had one backhaul link that was 700 megabits, and we had probably half of our customers, around 1,400 customers at that time. And 700 megabit is not enough for 1,400 customers, no matter how small of plants you're selling. So I threatened to quit, and if they didn't either upgrade the link or get some sort of queuing system so we installed Preseam over for that link. And I turned my life around there, and I was like, we went from every day, multiple calls a day of issues, to we bought ourselves months of expansion and growth and people not complaining. And so that was kind of my first experiences with queuing and proper queuing, and getting into making better choices about how we handle bandwidth, and improving the customer's experience. After that, Mikrotik was releasing router SV7, and I was one of the first ISPs in the world to put out FQ for being done on Mikrotik. I was running beta code so that I could do this. It wasn't really for the queuing. I was able to convince the boss for other reasons, but that was a side benefit. And I remember one day, it'd been a couple months after we didn't set it up, and I was like, I turned to my lead tech, and I'm like, I haven't heard you having to explain to somebody that their Xbox is the reason they don't have any internet. What the heck? Like, are you just like sneaking this by me? Am I not paying attention? And he's like, oh no, after you did that, was just stopped happening. Like, after this project, it's been great. I've had all sorts of time to work on my dev work. I'm like, so that's been my life. I'm a huge proponent. I try to help people a lot in implementing it in their Mikrotik routers. I know I try to participate in a lot of the conversations whenever I can in helping people. So what about you, Robert? How did you decide that FQ Codal is kind of what was the thing that helped you get on this train?
I had followed Dave for a while, and I had learned a little bit about buffer bloat, but I didn't know how it was impacting our network. I figured that it was probably causing some impact, and being a big do-it-yourselfer, I wanted to try, writing something. So I just made a little Python script that just set up the HTTPs, like the Linux HTTPs and the queues above that with FQ and used an old janky server, put it in line to see what it would do. And once I actually had it working, even without XDP or anything, I just noticed a really significant improvement. Like the calls we were getting daily, which were like maybe seriously like 4 to 5 a day. It was very frustrating. Just kind of dropped off, and I was like, okay, there's something to this. Like, what's going on? And then that led to open sourcing it and getting a bigger group together that was developing it. So Herbert joined on, and Dave himself was able to help us out to implement things correctly. So and then the pandemic hit. So I think we were a few months into development at that point, and once the pandemic hit, we really realized how important that was going to be. So we switched at that point from FQ to Cake, and saw a pretty significant improvement on like voice calls. So that's how we started, and I think the pandemic kind of accelerated the development quite a bit. But we saw it really helping customers, especially those on lower bandwidth plans, people in rural areas, people on links that we couldn't otherwise correct for one reason or another. We're finally able to get really equitable bandwidth. And like you explained, Tommy, like, situations where their Xbox is running in the background, that has actual implications for people's like livelihoods. If they're not aware that their kid's running a game update and they lose some critical call for their work function during the pandemic, that's a real life impact. So it was just really cool to see that kind of come together, and other people joining the project and seeing the impact that Prosim has had, especially during the pandemic, was really encouraging too. So yeah, we're just I think the beneficiaries of that. So yeah, we're just continuing to learn about it and try to develop something better every day.
So you mentioned the differentiation of Cake and FQ Codal, and we probably ought to kind of clarify that these are two different protocols, correct, Dave?
Well, yes and no. Could I just take a quick step backwards? I get really teary and choked up by hearing how much work you guys sunk into the pandemic. I have a slightly different story. All this work was concluded, 5 or 6 or 7 years ago. And at the beginning of the pandemic, all of the video conferencing companies rang me up and say, what can we do about improving our video conferencing quality? And I said, encourage your routers and the ISPs, encourage your customers and your ISPs to install better routers with this stuff on it. And none of them did. And I got fed up. And because there was seemingly nothing that I could do, I went off and I put on a music concert every Saturday, open air music concert. And I logged out of the internet almost entirely. So when you guys tell me the fact that you dug in and made it better, it really cheers me up. Thank you. So
I wonder, Tommy, if it makes sense to just back up a little bit, and maybe Dave can just talk about what buffer bloat is for a minute.
Yeah,
anybody coming in cold might actually just wonder what we're actually talking about right now.
That is actually a really good one. All right, so Dave, since you were been like one of the guys who coined the term, or were involved with that.
Jim Geddes is the fellow that coined the term. He's the inventor of the X Window system, and And he had actually been experiencing this problem every time he did an upload. His kids would complain to him that they couldn't do their games and their video conferencing. And he realized that it was actually a tremendously deep problem. And he'd gone around for about 6 months talking to some of the greatest experts in the field, Van Jacobson, for example, Ben Cerf, Nick Weaver, people like that, until he coined the word and started to try to prove to people this was a real thing. And basically, what buffer bloat is that you need a small amount of buffering in order to make sure you can sustain a flow across the internet. If you have a teeny buffer, you ever try to pour something directly into a Coke bottle, you know, some kind of small container, you end up with a lot of spillage, and that doesn't work very well. So you put a funnel on top of that. And buffer bloat is exactly that. You have a funnel that needs to be right sized so that the flow is smooth. And unfortunately, rather than get the size of the funnel right, the entire industry made a really sharp accidental course in the wrong direction around 2005 and made about 5 simultaneous mistakes. One of them is in Linux, we increased the buffer size from 100 packets to 1,000, not realizing that order of magnitude increase actually led to two orders of magnitude difference in latency. And things like Skype stopped working. Simultaneously, the cable industry massively did not get it right in the light of dealing with BitTorrent. And then further, wireless technologies, which are wildly variable, had absolutely no algorithms for coping with. Sometimes you need a really tiny funnel, sometimes you need a really big funnel. So that's what Cora's buffer bloat is. Is that a reasonable explanation, Dan? What other analogies do you guys use?
I usually always say like a traffic jam. I'm like, every time you get like traffic, you don't expand the roads. You don't start driving through people's yards. You
It happens in some countries, though.
Well, yeah. Driving around the FA is kind of scary a lot, but
yeah.
I'm like, no, you increase the time for the traffic lights and so on in order to regulate that traffic instead of letting chaos ensue. And as an ISP ourselves, it's like you can't buy new bandwidth just because some people decided to turn their Netflix into 4K. You have to regulate it. So like I've had some people say like, oh, well, this is just a trick. Quality experience is just tricking people, prioritizing speed tests like that. I'm like, no, it's just controlling that traffic to make sure everybody functions smoothly, has a good experience. There's a reason we got stoplights. It's the same thing. It's your road isn't smaller because of the stoplight. It's just controlled and regulated because of the traffic control.
Yeah, there's kind of two things going on there though. Like for the buffer bloat case, I think everybody's had the analogy I like to use is you've had this experience where a link at 90%, the experience is good. A link at 95%, the experience is garbage. That's buffer bloat. How you share bandwidth within that is a different thing. That's an allocation question, and we can probably have a somewhat controversial discussion on how you should classify traffic to make that happen and all those kind of things. But those two things are actually kind of different.
Yeah. So I think one thing that we did actually really have stepped over is, as an ISP, the main fact is every single one of us is oversubscribed. Oversubscribed to ridiculous amounts. Like you have to sell 4, 5, 6, 7, 8 times what you have purchased just to be able to break even. So especially as bandwidth requirements from the consumer side become higher, and their peak bursty what they are wanting to be able to get for speed tests, downloads, whatever. The reality is that they don't use their bandwidth all the time. and even nowadays, like BitTorrent, stuff like that, like the amount of bandwidth that is actively using is not like you can do a whole video download in a matter of minutes, not hours or days anymore. So the technology has vastly changed, but the fact that we have to sell we have a 1-lane road and we need 5 lanes worth of traffic. And we just have to rely on the fact that, okay, sometimes these 5 lanes are going to be more full than other times. And so now we need to be intelligent about when do we allow each lane, who do we allow when, and what vehicles do we send off to the side of the road to burn and go into oblivion, and making intelligent choices when we about, do we want to get the Mini Coopers or do we want the semi trucks? So really is the analogy I try to go for.
Could I've been dying to do this. Could I read you a poem aloud that Jim Geddes and John Morton, the founder, the principal author of Cake, wrote? Because all of us have these different interpretations, and I would love to just add them all to the mix.
Well, is it like multiple pages of poetry, or is it like a couple paragraphs?
I can be done in 1 minute. Ready?
Excellent. Go.
It was 6 men of interstand, to learning much inclined, who sought to fix the internet with market share in mind, that the evil of congestion might soon be left behind. Definitely, the pipe men say, a wider link we laud, for congestion occurs only when bandwidth exceeds baud. If only the reverse were true, we would all live like lords. But count the cost if bandwidth had no end, the money men say. But count the cost if bandwidth had no end, money men say. A perpetual upgrade cycle, and true madness lies that way. From diff-serve land, their tried and true solution now departs. Some packets are more equal than their lesser counterparts, but choosing which is which presents new problems in all arts. Every packet is sacred, cries the data center clan, demanding bigger buffers for their ever faster LAN. For them, a millisecond is an eternity to plan. The end-to-end principle guides a certain band of men, detecting when congestion strikes and inferring bandwidth then. Alas, old methods outcompete their algorithmic maven. The isolationists prefer explicit signaling, ensuring each and every flow is equally a king. If only all the other men would listen to them sing. And so these men of industry disputed loud and long, each in its own opinion, exceeding stiff and strong, though each was partly in the right, yet mostly in the wrong. Yet oft in these technologic wars, the disputants I ween rail on in utter ignorance of what each other mean, and prate about an internet that not one of them has seen. Jonathan Morton, with apologies to John Godfrey Sachs. You can cut it later if you like.
Oh, that's excellent. I will. Could you send me a link to that? I will put that on the show notes.
Great.
I love the data center guys.
Well, again, we all identified the different archetypes and stereotypes, and you have 3 different viewpoints already. So I added 3 more, and that's the dispute that we have, as we see different parts of the elephant here. You were just very dramatically talking about your need to oversell. And the thing is that this overselling thing that's happening today is that I think we're beginning to establish that there is a baseline bandwidth that no human or household is going to achieve with the technologies we have today. It seems to be about 4 to 5 megabits per subscriber from the numbers I've seen so far. You can't watch a Netflix movie with each eyeball. Actually, movie watching is something that's more of a social thing. So we are hit an age of peak bandwidth, and it doesn't matter if you have a gigabit link or 10 gigabits or 225 megabits. It really seem to be hit a wall here, but still using that efficiently and optimizing for the interactive traffic at all times is what I've always been about. I started working on this stuff before you were born. Some of you were born anyway, because all I wanted to do was transmit a guitar to a drummer over the internet and back and be able to play in the same virtual room. And that was back in the early 90s. And we're still not there yet.
Not quite.
Some people have already, actually.
There's some really cool new technologies. Drag Trip and FarPlay are doing it. And with our stuff, with Cake especially, and Line, you can do it now.
Yep.
So, all right. So we have all these different perspectives of the issue. Dan, what would be the, like, your, actually Dan and Dave, like, what is FQ Codal is the older technology, correct? And Cake is based.
You didn't manage to explain the differences between the two.
Yeah.
Okay, so I always do a shout out. The Codal algorithm was designed by Van Jacobson and Kathy Nichols. They deserve medals for what they did in reducing queue length with active queue management. Eric Dumaset, who also should be far more well known than his, came up with the revised fair queuing algorithms, which we call flow queuing in those two. The hope is that we would be running these algorithms natively, RFC 7567, across every device in the internet by now, and we wouldn't need to do that much else. It turned out that the first place, and Dan was one of the people that saw this first with pre-seam, is that the first place that we really needed this technology the most was in shaping to the plan and being able to have predictive bandwidth across your backhaul. And we also noticed this, and we set to work on developing Cake, which incorporated a lot of our own work in the SQM system. But let me pass it on to Dan to talk about how and why he picked up FQ Codal and so on.
Oh yeah, I mean, I guess the history of that's probably just home experiments. Like, I don't know if you remember, Dave, way back at the very beginning of the buffer bloat stuff, we ended up talking a couple times, and that was just messing around with things. Ended up finding a DSCP bug in the kernel, I think, at the time. At this kind of the same time you were digging at a bunch of the stuff, and all that experimentation at home combined with what I was seeing happening in the big providers on the DPI side kind of drove things to where they ended up, I guess, looking for something that I often say it Codal and then the fair queuing along with it, even if there's tweaks on top of that, it solves the fundamental problem instead of hacking around the problem. Like, really, the reason that, I mean, Dave mentioned earlier that all the BitTorrent stuff, the reason that ISPs had trouble with BitTorrent wasn't BitTorrent itself. It was that it was filling the buffers and hurting everything else. And there's this kind of instinctive reaction to say, okay, this BitTorrent traffic causes trouble, so we'll shape BitTorrent. But that's not solving the problem. It's just artificially reducing the traffic load to the point the problem's not visible anymore. And that's fundamentally what Codal and FQ Codal and Cake on, variations on top, is it fundamentally solves the problem. I really think all that application stuff, it's a hack trying to work around a problem instead of solving the actual problem. Unfortunately, it's going to be a while until every hop, in Dave's dreamland has an FQ Codal instance on every single port, just because of essentially the chips that are in some of those devices are bonkers cheap and bonkers simple, and they're never going to change. But that's what's so cool. Like, it fundamentally solves the problem instead of hacking around it. And that's what I like about it.
So all right. So we have two different pieces of technology: FQ, fair queuing, and then Codal.
Yeah. So Dave likes to beat me up on this. So, so there are two different things. So, sorry, Dave can jump back in a second too. But so the AQM part is Codal, which is when to drop packets for an individual queue. Fair queuing is dividing bandwidth across flows. The two of those things together are at the core of Cake and FQ Codal.
Okay.
And we tend in our marketing to often just call it AQM because that subtle distinction, I know it's important for maybe us, but like, it's just too much for the general market.
Okay. So, but we have an opportunity to dive in. So the fair queuing, what is that technology? Is it, my understanding is it's basically just hashing each flow and then putting it into a separate bucket.
With a behavioral bit. Do you want to take that, Dave?
Okay, so I want to clarify that fair queuing has existed since the 1990s. One of the original authors of it is a very famous guy. whose name is currently escaping me. Please forgive me, dude. He invented SFQ. Another group invented what's called deficit round robin. And there's another guy named Luca Muscarillo who also came up with this thing called SQF. So that's fair queuing, and you more or less have it right. But I'm going to say, like, say you have 3 packets. Here's a queue of 3 packets, right? They're all the same.
Your pictures. Yep.
3 cigarettes. And another packet arrives. It's a little different. It's from a different flow. Well, in normal fair queuing, this first flow would have 1 packet go out, and the next flow would have this different packet go out. And then it would serve the backlog of the other flow. Yes. And this is the single most important technique that we have for ensuring that interactive traffic stays very interactive. And it turns out that almost all of our traffic is very short packets, DNS in particular, but the first packets of TCP, gaming traffic, and video conferencing to some extent benefits hugely from fair queuing. Okay. I'm going to hit the AQM point, but I wanted to also say that our advance on fair queuing was even different. We call it flow queuing. And instead of serving stuff in a strict round robin order, if we see that the arrival rate of all the flows, if the arrival rate of a new flow is less than the departure rate of all the other flows, then it just goes out first and it observes no queuing at all. And it puts an incentive into the network for all applications to use slightly less than their fair share. And that's my dream, and that for the first time with this flow queuing algorithm, we have an incentive for all flows to try to use less than their fair share in order to get zero queuing.
So is this based off of packets or bits?
The present implementation is based off of bits, based on the deficit round robin ++ algorithm. You can actually do it with packets, and it may actually be a better thing to do with packets. However, the approach to doing that is patented, and we decided to wait till 2028 to do it. If there's anybody out there that would like to license that patent and try implementation that way, go right ahead. We feel our implementation using deficit round robin, is completely patent-free, and that's why we ended up going that way. Not just for technical reasons, but for patent reasons.
Okay, so and I think that hits up on another thing that I wanted to ask about. What is the licensing for FQ-Codal and Cake?
Well, FQ-Codal and Cake are FQ-Codal in particular is RFC 8290, and it is a patent-free algorithm that is put into the public domain and maintained by the IETF Trust. So we should have no issues with ever using that in anything, to our knowledge. Cake is a successor, and it's open source, and we do license it BSD and GPL, and I hope that other people will pick it up. We haven't put it through quite the rigor of the standardization process that we did for FQ-Codal, but so far 7 years, no challenges. So I don't worry about it very much. It's always been my hope, in particular, that Cake made it into BSD. We actually designed it to bypass some missed features in BSD, and so far no one's picked it up. So, oops.
Such is life. So, and then Dan, back, what is the Codal portion?
Yeah, so this, I guess, to oversimplify that is when a packet is queued into individual FIFO buffer, you store the timestamp. And if it is sat in the buffer for too long, you throw it away instead of transmitting it. And it's a little counterintuitive because you think, well, I've already held on to the packet. Why would I throw it away? But the advantage of this is that the lost signal gets to the other end faster and it will back off faster. So, and it also has the effect of dynamically sizing the queue, which is exactly what Dave was talking about earlier, where based on the backlog, it's going to drop more or drop less. So instead of queuing up 100 packets, when it will slowly shrink that down just based on the head drop to just have enough bandwidth to maintain the throughput on the TCP connection or the quick flow or whatever that is. Probably slightly oversimplified, Dave, but.
Well, any chance they get through it, absolutely. To start, so I wanted to clarify, there's a lot of theorists that believe that with perfect AQM, you can get by with just AQM. If we had an oracle.
You mean AQM without flow?
Without flow or fairness queuing, they believe that they could do it perfectly. And unfortunately, that attracts a lot of academic interest to date and results in one kind of failed paper every year. And I kind of gave up. Putting fair queuing into the network helps. But effective AQM was also really, really necessary. Another major innovation of Kalo was the head drop concept instead of the tail drop concept. And the previous premier technology is called RED, and another one's related is PI, is tail drop. The beauty of head drop is that you provide immediate signaling. Hey, you look, you lost this packet, here's a new packet. And then it just, it's an amazing innovation overall. You know, when we first saw it going, we saw reductions in 2 orders, 100-fold reductions in internet latency by using just the Kalo portion of the algorithm. It's just
Okay.
amazing.
The Caudal paper or whatever that's in the communications of the ACM. Maybe I can get you a link for that later, Tommy. It's really easy to read. You should just read it. It's super interesting.
Everybody should have read that one. Yeah, it's up there, as well as his prior work. You know, all of Van Jacobson's work is really tremendously worth reading. He also gives a wonderful talk at IETF about it. If I could just pass that along to convey that intuition to more people about how the internet really works, it'd be great.
All right. Well, I've been asking a boatload of questions at this point. Before I dive into more engineering weed stuff, Zach, what's been? I didn't get to you what your experience was about queuing and dealing with bandwidth issues. So, what have been your experience, and what are your questions at this point?
So yeah. Started this WISP here in 2016, so kind of pre-pandemic. Everything was very all ubiquity equipment and just using the built-in traffic shaping, which is, I guess, policing, not shaping technically, but lots of calls. Hey, my Netflix, my games, everything's terrible. Got to the point where we're just like outgrowing being able to manage all of that and constantly, hey, I want to change my plan. We got to log into the router, do all the stuff. So it wasn't so much the phone calls that prompted me to start looking at, okay, what are some options for actually doing the plan enforcement? And that kind of led me down the road of, oh, well, now not only do I get plan enforcement, I get better user experience. So I kind of came about it in a little bit different direction. It wasn't so much like, hey, it's, because there was always an explanation, right? It was, well, your Xbox is downloading games, or your, Netflix is, you got 5 people streaming Netflix on a 5 meg plan. Well, you can't do that. So it kind of brought me around a little different direction. Was like, okay, well, we just want to do plan enforcement to reduce our overhead and not having to, manage all these different routers and changing plans. And as a side effect, we dropped Siemon and all these calls. Well, not all of them, but a vast majority of them stopped. And I was like, okay, that's kind of interesting. And that's kind of what drug me down the more of the QoE experience. And I'm actually running both LibreQoS and Perseem in different environments right now. So I've kind of been, I've likes and dislikes with both, but my question, on kind of both of those projects is, where do you see that? Like, where are you positioning? And this is more of maybe like not so much a marketing thing, but like, for those projects, what is the focus? Is it ISPs? Is it individual users? Because I've actually considered putting that in businesses or places with low bandwidth connections, even if I'm not servicing them. Say, they've got a connection from cable company X, dropping a LibreQoS box in or a Perseem box in to do that queue management for them if they don't have a Mikrotik or whatever to do FQ Coddle. Is that something that you guys have seen? Is that kind of what are your thoughts on that?
I guess let's go first, but we're not really designed for that. It's entirely all the integrations, the network polling, the network discovery, the way individual instances are managed in one cloud instance and stuff. It's not really designed for having hundreds of boxes or, spread across a bunch of individual customers. So that's just not a space that we're trying to do anything with. It's pretty trivial to set up a little traffic shaping box in Linux or put LibreQuas on it for that use case, but that not something we're focused on right now. Every once in a while I flirt with it because it would be kind of interesting, but just even the way the authentication works on our cloud and stuff like that, it's just not ideal for that use case.
Sure. Yeah, I do some work for some like managed service clients that they're like, well, we have what we have. We can't get any more, and we're trying to just eat as much out of it as possible. So
this sounds like a Robert moment.
Yep.
Yeah. Well, with LibreQOS, we've recently we have kind of the same dilemma that I think Prasim does, which is that our integrations are really focused on ISPs. But one benefit has been that we're starting to focus more on how are you going to scale this to have multiple boxes. And I think with the long-term stat system that we're building at the moment, it's getting a lot more feasible how that's going to be laid out. So I think for enterprises, it's going to be helpful there. If you want to have multiple boxes and you need to rate limit it a certain amount for the WAN, I think it could be very useful. Especially, I think LibreQOS has appealed to a lot of folks who want to do kind of custom integrations. So I think it's helpful for that. So I do think it's going to be more relevant for enterprises in the future.
I really like the stats also.
All right, Dave. He's waving his hands. Give him a chance to speak.
Go for it.
So I am, principally a researcher. Cake was our latest creation, and it's only beginning to hit the market now. And we have all these other really cool new things happening. And even expressing how the internet really works to most people has been difficult. So I've been really loving seeing the new packet analysis techniques, which are all released as open source as well, based on Kathy Nichols' work. Yay, people can see physical round trip times. And I have some plans on looking more deeply into QUIC. And one of the cool things that happened recently, I'm sitting there looking at how Netflix works through these cool new pictures. And we then Trendle ran a test of Amazon Prime, and it looked very different. So that started a conversation with me about why Amazon Prime was working so badly with Amazon, which turned into a contract. So what I want to do with all this technology is to continue to push a better internet forward and to leverage the kind of information and data we're getting to improve our transport protocols and to make video conferencing better and to make gaming better. So my long-term picture is that we are going to keep reinvesting all of our efforts into making the internet better across the entire internet, and there'll be new markets appearing for everybody, including for free Siemon, for LibreQOS, that we will hopefully expand into and keep making the internet better. So for me, it's the chance to do science on a grand scale, to see how. Here's another. Can I throw another statistic at you? It was really cool. I was a big believer. It hurts me. One of LibreQOS's biggest clients in New Zealand shared with me their drop statistics. And in order to do good congestion control, they were dropping anywhere between 1% and 3% of all packets shipped all the way to New Zealand, which means they have to be retransmitted. That hurts me. There's an energy cost to that. So there's a new technology called RSC 3168 ECN, which would prevent that. And I've been trying to get more people measuring it, more people using it, so I can save 1% to 3% of all packets. It's one line to turn on this facility in your operating system. And so having that big picture of how to improve transports and stuff, that the future is so bright, we all got to wear shades.
So the explicit congestion notification bit. Oh, ECN bit. I love the ECN bit. I learned about this through working with FQ Codal and Cake, and that it blows me away that no other technology has been utilizing the ECN bit in any explicit or like significant way.
I think the problem, I'm not sure it's quite new, Dave. It's been there for a long time. The problem is a bunch of ISPs and across the wider internet, they scrub those bits. And that's like, it's maybe not as prevalent as it used to be. And I think it's probably much better than it was a while ago, because it really used to be a disaster. But if your ISP in the middle is like resetting all those bits, then you just lose that. And it's been a barrier for deployment for quite some time. But Dave probably knows this better. Some of the recent numbers I've seen look like it's not. Maybe it's getting tractable now.
I keep hammering at it. I hope it gets better.
Yeah.
Why would they be changing? Why would they be scrubbing that bit?
Because it's in the same kind of group of bits as the priority fields, the DSCP fields. And there's a long history of people just whacking that to 0 as it comes in and out of their network.
Okay. So that, yeah. And I do recall that. And I remember when I was first like looking at prioritization stuff, like getting exhausted with it and being frustrated because like half the stuff that gets to me is not following any kind of prioritization.
Right.
And
Yeah.
and
Exactly. It's either scrubbed or it's not set to useful values.
yeah, or frequently like an ISP is not going to regard them at all. Like they're just going to treat all packets the same.
Well, one of the new features in Cake was the ability to observe these bits being used, as well as to take intelligent decisions based on them. And we are seeing a significant amount of cell phone traffic in particular landing in the right queue, which is good. And we're seeing what seems to be a goodly deal of video conferencing traffic landing in the right queue, and the bits being preserved across the user base that we have today.
So, then now we're mentioning it. We've been talking about FQ Codal for the last hour. What are the improvements? What changes from FQ Codal to Cake?
Okay, I guess that's me. There's papers on this. Anyway, for starters, it uses a improved Codal algorithm that is more accurate at almost all scales. It uses up to, we typically use it with 4 bins of diff-serve classification. It drops slightly less packets, and particularly in a specific scenario that I actually didn't believe in. It tries never to drop the last packet in the queue, which seems to help on user traffic. FQ Codal is smarter here. It will drop the last packet in the queue, which makes a lot of sense in the kind of scale FQ Codal is run on. But for Cake, it makes more sense to not drop the last packet in the queue. Aside from that, it does ACK filtering, which is proving pretty useful and saving on uplink bandwidth in particular. And it's slightly faster response to slow start, a couple other technical features. It is marginally better in every dimension that we found with the initial deployment of the SQM scripts, with 5 years worth of hacking on it to make sure it worked the absolute best possible at the lowest bandwidth possible. So it's we had hoped it would be the successor to FQ Codal, except that it uses up a significant amount more CPU, and people are gun shy about using that up, even if they put perfection. However, if you got plenty of CPU to burn on a cheap Xeon box, and go for it.
Okay, so higher CPU utilization, but has a lot of other features, and that's what I've been seeing. So on the diff-serve, you mentioned that diff-serve 4 is the default. I tend to run diff-serve 8 just because it's like, well, if I can turn it up, I might as well. I like turning my things to 11. So what would be, you mentioned that, what is that as a tool?
I have to say that, diff-serve is the last thing of all the things you should care about. Fair queuing first, AQM second, and a couple other features. Diff-serve is just so horribly contentious as to how you classify traffic. It really is. For example, Paracom, who's also using Cake, is also using a diff-serve 8 model, maybe even something bigger they embedded. In my case, I decided long ago, there's a rant of mine, Wonder Shaper must die. And I talked about the popular Wonder Shaper script that we started to use in the 2000s. And we pretty much firmly established that there were only 3 or 4 bins that people really cared about for what traffic went into. Voice and gaming pretty much belong in the topmost bin. Video conferencing and interactive traffic like that belong in another bin probably. And there's normal traffic. And then I actually think this is the most important bin of all. There's background traffic. There's plenty of things that you really don't care how long they take. You just don't want them getting in the way. BitTorrent classifies as this, So that's the basis of the diff-serve 4 model, was trying to get that overall approach. And that's what pushing for standardization, and of course, everyone's got their own view. DiffServ 3 is actually default for many people too. But when video conferencing became so important, we decided that DiffServ 4 made the most sense.
Okay.
I guess the key there, though, is the applications have to adopt it.
Yes,
Which is unfortunately very inconsistent.
As best I can do is put forth a standard the way I did, and with enough people using it, we tried really hard to match, for example, Zoom's markings with that. So Zoom optionally has a set of markings that will fit precisely into the cake bins. And we did it in a couple other protocols. It'll be years before it sorts itself out. But it's a step forward versus the chaos that existed before.
So, and there's actually quite a few other things, as I recall, in the DiffServ. It's highly recommended to not use best effort.
No, everything is marked as best effort. You should, anything you don't strictly care about, fair queuing and AQM will do the right things for you, really.
Okay.
Honestly, it's, you have a really, really, really big backup that you don't care if it takes overnight or not, and then market background. You have a VoIP or gaming flow, then market foreground. What you shouldn't do, and this is one of the advantages over the DiffServ implementation cake versus what existed, it's not a strict priority queue. And what I mean is that if it used to be on some setups, if you marked everything with the EF code point, then it would eat potentially all the bandwidth for itself and be greedy. And that's not fair. That's not the right way to go about it. So cake gives it 6.7% of the total bandwidth. If you go over, you don't get any benefit. But for VoIP and video, VoIP and gaming is so small that you never even get close to those kind of percentages. So we put an arbitrary set of buckets for each major code point in it. And I hope that that's, again, something that propagates along the edge.
Okay. So cake, very frequently I've, heard and it said, like, you can use the defaults and that's going to be pretty routine. But a lot of guys are going to want to adjust and modify and use various other cool settings. One of them being auto rate ingress. That's
the single most problematic part of cake. Okay, so can I just stop you there for a second and let me rant? There's a wonderful project that's tried to leverage active measurements of how 5G and Starlink work. It's called SQM auto rate. It started with the auto rate code as a base, and it has come a really long way. I thought those guys were nuts when they started, but at 3,000 plus messages and all kinds of analytical scripts and methods later, I've been highly recommending that people stuck behind 5G in particular, as well as Starlink, to give it a shot. They've come a long way. So yeah, go ahead, touch that wet paint. But as written, the cake auto rate code in cake was not adequate to the job. It was a good idea, and maybe someday we'll come up with something better and put that into the mainline cake algorithm.
Okay.
So sorry, a little twitchy. I mean, we were talking guys that have spent many, many man years now trying to make this stuff work better. And my hat's off to them. And if you're that kind of person, please join them and get back to me when you're done.
Yeah, it seems like it's a very difficult problem to solve. So Robert, what was your reason? So I think you were saying that you started off with FQCodal and then you went to cake.
Yeah, originally we were using FQCodal just because of resource constraints. I hadn't really optimized the code. It was just a single Q giant HTB running in Linux. So on the constraints of the box at the time, FQCodal seemed to make more sense. So I just tried that out, especially knowing that Perseem used FQCodal. I was like, well, let's try that. That should be sufficient. And it definitely helped. Especially it's really important to have that versus just using HTB by itself. But we tried the switch out of curiosity to cake once we had the resources, and we noticed a pretty instant improvement for VoIP and for gaming. And gamers are really particular, especially on fixed wireless networks. Like they know, they can sense it, they can see when something's a little off in the latency. And it finally kind of quieted that crowd. Like they seemed very content. And I didn't understand why. So I talked to Dave about that, and we started investigating like what parameters should we be using. But we did notice a pretty 9-day difference between FQCoddle and Cake. That said, I know Persim uses a more adapted version of FQCoddle, and I can go more into that. But we've noticed that Cake with diffserv 4 has been like perfect, like for every use case that we've encountered.
Okay. Yeah, I'm a pretty big fan of FQCoddle because especially implementing in the Mikrotik router space, we have limited hardware, memory, and we have issues with CPU. Admittedly, FQCoddle uses less memory than PCQ queues, which at least on Mikrotik. So that's just how that boiled out last 2 years ago. But I've really have stuck with FQCoddle largely because there's been some bugs in Mikrotik's Cake implementation, and there were some weird issues with smaller hardware crashing, and then also just the CPU requirements. That's like I really get like I don't like we're already doing NAT, we're already doing firewall, we're already doing all this other stuff. It's like I really don't want to push stuff too hard. So that's where I've stuck with FQCoddle. Dan, you've mentioned that you guys have a modified FQCoddle, and that's how you guys work with your system.
I mean, modified, tweaked, I don't know what you want to call it. Like one of the big things there is we just use a lot more bins than the default, so that any chance of any type of flow collisions and stuff is just unlikely. The biggest, I guess I haven't looked at this in a while. I know when we spent some time back in the day looking at the TOS parks, and Dave's looked more recently, he might have more recent information, but there's all kinds of interesting behavior of like apps sending, like you'd send on one code point up, and then the downstream traffic would be different, and it ends up in a different bin, and there's like all kinds of fun business that happens there. So that just really hasn't been a focus for us, mostly because what we found was where people were struggling wasn't that last little bit of prioritization, it was sizing the bandwidth to the APs, right? Like if an AP is busy and dropping packets, it doesn't matter if you get that last 1% out of DSAP marks, you're in way more trouble. So we've just put a slightly different focus on the analytics and the scores and that side to try to solve that problem versus optimizing on the DSAP bits.
Yeah, and you guys are taking in information from the access points and such, and creating a feedback loop, as I recall.
Yeah, especially on the scores and then on the auto shapers as well. Yeah.
Mm-hmm. Yeah, which I can't really do that effectively in the Mikrotik world. I mean,
it just takes a lot of data. It's a different, it's kind of, eventually, we'll probably get back to looking at doing something with the DSCV bits, but it really, again, a busy AP that's dropping packets, it doesn't matter how smart you are with Cake, how smart you are with FQCoddle, you're in a lot of trouble. So you got to solve that first.
Oh, hey, yeah, that's actually a good question. So, Zach, what, like you're using both, what do you see as far as your use case?
So I don't have enough traffic on LibreQoS yet to, I guess, really make it a good comment on that. I mean, obviously like I stated earlier, with dropping for Siemon, stopped a lot of phone calls. Obviously they're using FQCoddle. I don't have equal amounts of traffic going through both yet. So I may have some more info on that in the near future here, but so far, I mean, they both like do what they claim. So, which to me is reducing support calls. So that's kind of the main focus there. But so it's like it does what it needs to do at the moment.
Yeah, if you're already pretty converted to one religion, in a slightly different sect, it's not all that different. It's defining the people that haven't already figured out that these technologies improve the customer experience. It's finding those people and making sure they go do that for the rest of the internet that I care about most. It's great to have the converted. How do we fix the rest of the internet?
Yeah. Well, and oh, keep going.
I'll just say, just keep talking about it. I mean, I didn't know about any of this till, somewhat recently. So it was, like I said, I came about this a little bit differently. Like, we had UGOBs of bandwidth. We had a gig pipe and we're using 100 megs because it was just cheap bandwidth. And the previous owners had bought a giant pipe. So, John Osmond's thing is always, I'll just build bigger pipes. So that's literally what we had. So we didn't so much have the, massive, like we're trying to oversubscribe everything, a dozen times. So I just had a little bit different journey into that, but it got me here. And now it's just talking with more people and getting the word out. I think that, hey, this stuff exists and it can solve your problems.
Yeah. And maybe just to kind of add to that, like so the congestion is not just on links, it's within the plan rate. And that's like, I think that's what was kind of missed for a long time. And people were just doing the FIFO queues within the plan rate, and the customers were congesting themselves. And that's what these techniques fix. It's a virtual link that got full, and the link got full. The experience was bad.
And I need to really offer, I always said this, every network connection is potentially congested on a very small time scale. I've given a couple, really tried to talk about this, but TCP traffic, a single flow, will double in its bandwidth every round trip until it hits a wall and drops a packet. And so one of my complaints today was that most ISPs were looking at 5-minute averages, and I would vastly prefer you look at 10 millisecond intervals, which is what you need to actually see the level of detail. By the way, I have a recommendation. Recently I reread James Gleick's Chaos book, which talks about this kind of behavior. And if you reread that, then you say, aha, maybe I should be looking at this at a finer grain time scale. So I'm going to return you back to this thread. Recommendation, read the book on chaos.
Yeah. And that is, the time scale factor is a really important thing that a lot of I think a lot of monitoring systems really do skip over and kind of gloss over it, because it's simple. We need to look at 24 hours. Okay, is this customer up, down, are they passing bandwidth and such? But even the megabits per second, that's an eternity in the compute space. And looking down, getting down to a 10 millisecond window that you're looking at and you're doing bandwidth measurements over, that's where FQCodal and Cake are going to be working and operating. And that's just such a tiny space, though, for humans. Like, it's really hard for us to understand how much that's going to affect our customers' bandwidth.
Preach it, brother. Kilobits per millisecond would be a much better way to think about bandwidth.
Ooh, that's
everybody's stuck on SNMP monitoring, which obviously 5-minute polling or whatever, maybe 1 minute polling. So
yeah.
A web page typically loads in 3 seconds. If you're sampling every second, you get 3 data points. You don't see it. We're seeing this still. The industry is actually moving towards some better benchmarks, TR-461, but they're aiming for 100 milliseconds. And no, human response times are down below 20. Video conferencing is 16. The metaverse requires 4 milliseconds. So,
yeah, but I think the key there is the AQM, the fair queuing with, that has to operate on those scales. In terms of and understanding the network, you need that. But your day-to-day operations, you don't need to know that, right? Like, you need to have that thing monitoring, and controlling at that granularity, but you're never going to take any real actions on 10 millisecond data points outside of debugging like an individual subscriber in real time.
Yeah, an engineer.
I have a different future in mind, one where we can interact in a highly virtual environment with no glitches. And
oh no, the traffic part absolutely needs to be responsible about that. I'm just saying from an ISP standpoint, you need something that's taking the actions and maintaining the quality at that interval. You don't need to look at individual subscribers at 10 milliseconds on a regular basis. That's just, that's not tractable at scale. It's not tractable even in your time.
Okay. Well, I said I was discovering a big problem, what I think might be a big problem with all of AWS by looking at stuff on that interval.
Oh, from a science standpoint, totally agree. There's all kinds of neat stuff at fine intervals. Yeah.
Cool. All right,
Yeah.
we're back on alignment with each other.
Yeah.
We engineers are going to need
Yeah.
that at certain times and days, and figuring out and hunting down issues. And I don't know if I have any tools in my tool chest that allow me to do that. But you know, your level 1 tech, your consumer, that's never going to be something that they really are looking for. What about like and going back a little bit to limiting, and we've mentioned a lot of TCP, but like, what's the difference in limiting TCP versus UDP and you know, all these other protocols that we have on the internet that we're interacting with, and these new protocols coming in? Oh, it's somebody. Oh yeah, right, Dan. You actually were mentioning you might have a rant.
Well,
So
an interesting thing. So, or interesting to me at least. I mean, they mentioned earlier too all the kind of the future of transport protocols, and what's happening with Quick there is super fascinating. Like, I don't know if everyone's aware of this, but Quick is essentially a new transport protocol, runs in user space, so it's part of the application. It's not in the kernel, and it implements all the goodness of TCP at that level. So you get reliable streams, or you get unreliable streams, and you get multiple streams within a given network flow. And it's really cool. Like that, if you think of the problems with TCP, the main reason that games and video and this call isn't using TCP is because of the head of the line blocking problem. If it drops one packet, it can't deliver the ones after it until it fills in that hole, because it's an ordered stream delivery. And Quick solves that. So we're seeing a lot of traffic start to move to Quick. All of YouTube is Quick. Most of Google is Quick. It's going to be it is the basis of HTTP3. So in theory, the whole web is going to move to Quick. And this is different, right? Like you no longer get to see the transport level headers. You can't proxy Quick. You can't do, you know, funny business with terminating the TCP connections in one side and optimizing them out the other, because it's all entirely encrypted. And it's just, it's super interesting as a protocol guy. Like it's super interesting to see, but it's a good chance the internet's going to look quite a bit different 5 years from now.
So I'm going to, like, when I started off, UDP was less than 5% of my overall bandwidth. Like TCP was when I was looking at my connections, there was a wall of screen of TCP, and like maybe once in a while I would see an ICMP, and then every once in a while I would see a UDP. So and Quick is using a UDP as the underlying protocol, correct? If I recall correctly.
Yeah. So that's basically, you can almost think of the UDP header as just like, how do you demux into a process of the operating system? That's really all UDP is doing.
Mm-hmm. Okay, so then, yeah, it gives you a source and destination IP, and then source and destination port. Call it a day. Dave. I'm getting waved. Oh,
I just needed to click on. So the really cool innovation, Quick should be its own bloody protocol. It should have another option that just makes it be a protocol, because it gets rid of the whole idea of port numbers in favor of what's called a GUID, one big number to rule them all. And it doesn't even need UDP. UDP is kind of in the way. However, I'm going to deliberately take a very opposite course to Dan, just for debating purposes. And it's not just Dan, it's the whole idea. I wrote it here: one protocol to rule them all, and in utterly encrypted darkness bind them. There's a lot of people that think that improving our end-to-end security in this way, and it has some great stuff like, you know, zero RTT crypto, improvement over TCP. But it means that you, the operator and owner of your network, no longer has insight into the traffic exiting your network. And while you might trust, to some extent, a Facebook or a Google, seeing packets land in Timbuktu somewhere you have no insight whatsoever into is kind of nerve-wracking to me. It's also been nerve-wracking to Paul Vixie in particular, who has decided to arbitrarily block Quick. So I think that in addition to the initial enthusiasm for a goodly portion of the internet using Quick, you will see major corporations and terrified homeowners actually blocking it to make sure that their light bulbs weren't spying on them.
Yeah,
There's
but that ship sailed a long time ago with TLS and TCP, right? Like,
Well,
the only thing that Quick's hiding is sequence numbers and stuff. Like, unless you're going to block TLS and TCP, you don't get any privacy benefits out of blocking quick.
Well, we'll see what happens. You can at least intercept the SNI. You can know what the heck is trying to encrypt to using the TLS method. I also want to make another negative approach towards quick, again, mostly for the purpose of debate. We'll see what happens in 5 years. In that TCP is presently vastly more efficient in terms of CPU resources than quick is. And TCP also does not require crypto. And I've really enjoyed working with the passive ping stuff we're using in LibreQOS to actually use the headers to debug networks. And I'm happy that we're doing that. You know, like we fully deploy all this stuff to get a good insight at not only what's happening locally, but deeper into the network. So it's a little invasive, but then all that goes away, and then we have even less ability to understand and debug networks than we had before. You know, I love using Wireshark. It's tremendously helpful. So those are 2 other darker futures for the quick protocol. Go ahead,
Yeah, it definitely is. Not being able to see some of those headers definitely has some impact in terms of how you can debug things. It kind of makes me wonder, and the ship has sailed, unfortunately, but that most ISPs should, you know, perfect world, again, probably can't ever go back, but should almost be running some kind of underlay where they can add the headers that they want for timing and all, like, you know, the int stuff. I don't know if you've seen like what the P4 guys have been doing. If you can run that underneath, you can get far better timing than you could ever get from having to snoop TCP headers. But the lift to have that kind of underlay under subscriber traffic everywhere is probably not tractable for most ISPs.
There were some interesting proposals for expansions to the IPv6 header coming from several Chinese companies. Bear with that how you will.
So you mentioned IPv6, and that's actually is something that I'm kind of curious about, and I've talked to Dan about this. So in when you're doing, you know, at the ISP level, you can only, you know, bandwidth limit to the single subscriber, because in IPv4 space, you know, a subscriber gets 1 IP. By and large, you know, there's many exceptions. It's the internet. It's the thing of exceptions, but by and large, each subscriber gets 1 IP, and all of our subscribers are using NAT to translate their inside network to the outside internet. And so that really masks what you can see of who the endpoints are and what other bits of congestion you can interact with further down the line. So with IPv6, though, we can see individual hosts and connections, and we can track all of these things uniquely and separately. How does that, like, what opportunities do we have as an ISP, you know, from above, like saying, okay, you know, maybe we can talk to, you know, oh, I can see that this one endpoint has high latency and it's taking forever to communicate. Like, is that possible to interact with and such, or is that just something outside of the realm of reality, just because the memory takes too much?
The things, I'm also going to jump into SI too. The problem that we were talking about there is one of long-term storage, because the IPv6 privacy addresses, they create random addresses constantly. So if you try to have long-term storage with byte counts per IPv6, the bottom 64 bits, the scope is almost infinite. Right? You like, especially us being like cloud-based and stuff, you just can't do it. Like you could do it in short intervals, but to have long-term stats for every single IPv6 behind a customer, it's just not going to work. It's too much data long-term. Short-term though, for like investigations over a shorter time frame, looking at the flow table, you have to have all the complete 5-tuple to build a flow table. So you can use that for debugging. But the long-term stats for IPv6 gets to be a challenge because of the fun privacy addresses. Like I could open up, look at my computer right now. It's probably got half a dozen IPv6 addresses, and it's probably moving between them over time. Right? That's the whole point of that.
Yeah, one of my hopes was that we would actually end up using. I would love to see more VPNs using IPv6 and say 1,000 IPv6 addresses to multiplex stuff over, make it even more confusing and make it easier to fair queue.
Yeah, I have. I just did an IP config on my computer here. I have 6 IPv6 addresses. 5 of those are temporary. One of them is preferred, and the other one, my real IPv6 address, is in use. So yeah, and this is me doing a Zoom call and opening up a few web pages, so Google searches, so that I can, IETF this, throw this stuff onto the Google Sheet. So at the end of the podcast, everyone has a million links that they will go off and read. So yeah,
I wanted
that
to
is
add,
huge.
can I just add, there's a flaw or a feature, if you want to think about it, in FQCODL. In the design, we assumed basically one IP address per host. So if you have a host that has functioning IPv6 and one or more IPv6 addresses, it can theoretically get 3 times, if you have 2 IPv6, 1 IPv4, you can get 3 times more bandwidth to that host by doing so. And we viewed that kind of as a feature because it would optimize for the hosts using IPv6, but it may turn out to be a problem in the future when people say, I'll just give myself 1,000 addresses and eat 1,000 times more bandwidth. And then we'd have to add some MAC level filtering to it.
Or you just have a separate instance per customer, and that goes away too.
Yeah, it depends on your viewpoint.
What
part of the network you're in.
Yeah, so like for me, I just bandwidth limit off of the whole /56 that I give to a customer. I say, okay, this 56 has this much bandwidth. Make with it what you will. I just tell it in Mikrotik. I just give it here's the IP address. Boom, done. I'm not playing around any games with it anymore. Actually, nowadays I do a VLAN to each customer, and then I just bandwidth limit the VLAN because I'm really lazy and I don't care I don't want to know what the IP address is. I don't care.
Yeah.
But that's in the reality is that a lot of ISPs are going to be like, okay, this is the customer, this is the IP. IPv4, it makes it simple, but in IPv6, as long as the router's able to say mark that, capture all the traffic and put it into the proper queue of FQCODL cake. Robert, is that kind of what you guys are working with? Are you playing around with IPv6 at all?
Yeah, so my network is like dual stack, and a lot of folks who use LibreQS are dual stack. So we basically just direct, for example, like you said, if they have a /56 and IPv6 or a /32 for IPv4, we just direct all that into a Linux traffic control queue disk, and then from there everything is shaped by HTTP and then by cake.
Okay.
But it tends to work well.
Okay, so unfortunately we won't be able to shape individually customers, but because they change too much, it's so awful. Curses privacy. Making the internet worse. What about other protocols? Are there any goofy protocols out there that act weird when shaped?
There are 2 actually. This is like the biggest bug that FQCODL had. We made it be the default in Linux. And then 5 years later, it started making it into the automotive industry. And it turns out that the CAN bus absolutely relies on packets being delivered in order and not dropped from the head. And I had more than a few nightmares about sneaking into the automotive industry, cars blowing up and stuff like that. So after quite a bit of verbal violence between me, the people in the CAN bus industry said, well, you should revert FQCODL across billions of devices. And I was like, no, you should just create an exception for the CAN bus, and we did. So, but there's a couple years worth of backlog where I'm still concerned that there may be some devices that may not be operating with the CAN bus directly, and my location is not physically known. The other thing that we've seen is we've seen quite a few older protocols for IoT that really hate drop. They just have assumed that the underlying network was reliable and it would get through. So, oops. But those protocols are wrong by design.
Yeah, the internet doesn't promise delivery.
Yes,
Mhm.
so I'm not so worried about that. There's been some new work on this thing called DCCP. This is my other kvetch about Quick is that it's polluting, and again, I'm using a hostile word, polluting the UDP space, which was prominently the space where we had VoIP and video conferencing live. It should be on its own protocol number. I know it'll take longer to adopt. I can't think of anything else. There's so many other retired protocols. UDP Lite, I would like to see more of. VRP, can't think of anything else. Somebody file a bug report when it happens.
Duly noted. That would be actually hilarious if but VRP I think is I think that's a UDP. Isn't that UDP traffic? It just marks itself because
It's UDP or UDP like.
Yeah.
And again, it only happens on one link.
Yeah.
So
And that link should never be congested, at least in theory. All right. Well, so how about like working into implementing bandwidth limiting? I know, Dave, you are a fan of putting proper queues at every single point inside of your network. Every single switch should be queued. I'll take that as a yes.
RFC 7567 should be my license plate. Really, the FIFOs, I mean, my overall thing, FIFOs must die. They are the worst form of queuing ever designed. They should die. They should vanish from the internet. Matter of fact, from the whole world, worst form of queuing. So, and, but anyway, I'll let you continue on your question. Thank you for spiking my blood pressure.
No problem. If I, but the reality is that most of our switches just are not going to be powerful enough to handle that and aren't going to be able to handle it for years. Although I am getting, I do have a manufacturer who was like, "Oh, really? We would love to talk to this." So I will maybe putting together another conversation between you and their engineers to be like, "Hey, let's see what we can maybe work on here," because GPON could probably use a little bit of this stuff.
I'm certain that the GPON would benefit. I worked on an FPGA version 7 years ago. I ran out of money. It would have worked. I didn't have enough money.
Well, so when you're implementing this and such, for me, like I do my bandwidth limiting at the tower, and so goes to an access point, maybe a switch in between, and then goes to over the wireless link to the customer. A lot of other people were doing bandwidth limiting at a core central point. The like premier bandwidth limiting spots are going to be at the CPE and then at the edge, and then you know stuff coming from the internet is going to be limited when it hits your edge, and then coming from the customer, it's being limited as the customer's upload. So those are the like premier optimal points. Where do you guys end up enjoying putting your queuing?
With us, the idea is we make sure every single customer has a Mikrotik. We have some customers that insist on using their wonderful Google Home things. You said no bashing, so I'll leave it at that. But, we're like, cool, you can use your Google wonderful thing. We're still putting a Mikrotik here as your handoff, your demarc. So one thing that I want you to work on later is actually setting the QoE from that device to the POP, and then from the backhaul to the actual fiber side. So that way we'll have quality of service all the way from that router all the way back.
Yeah, you're probably going to be one of the first ISPs I'm going to work on to like actually be building it through every single stage. I'm super excited about this project.
Because how we've done it up till now is just keep getting more fire hoses. Like we have tower sites that are fed from 4 different fiber connections of different locations. Because we'll just get where fiber is available, and then point to point it to a tower site, which it's been good up till now because we have really good redundancy. Like it almost never goes down completely. It'll just get slower, more latency, slower, more latency if, because we have brownouts here in Arizona a lot. So we'll have sections of town that lose power, and we actually do have people that work from home that invest in battery backup and things like that for their workstations. So they put their router, computer, everything on that, and they're calling us when the power goes down because they were working and they had no idea they didn't have power because they're running out of battery. Like, oh, your neighborhood has no power. So, but other than that, so we'll lose like 2 or 3 links at a time, but internet doesn't go down. They just notice I'm lagging on my Zoom, and we're like, yeah, there's no power at 3 of the 4 backhaul sites. So
What about you, Zach? Where do you, and you're using both, so you're doing kind of centralized?
I've got 2 separate networks. So one network's using Perseem at the edge, just because our towers were, well, I'll say the network was built as a hobby, and we're now trying to transition it to be a business. So if that gives you any indication as to where things are kind of at, we don't have facilities at towers to put shaper boxes or anything like that. We've recently started moving off of like little $40 Netgear routers to Mikrotik routers as our default. And then we'll put a Mikrotik in, kind of like what John was saying, with as the handoff. If they want to use their own router behind that, that's fine. More so just for management, but ideally shaping would come, eventually. So we're kind of heading that same direction.
Mm-hmm. There was a network not built as a hobby.
Well, this one was like retired gentleman, and was like just kind of worked on it as he felt like it. So lots of duct tape, lots of electrical tape, and baling wire holding stuff together.
They're all that way.
Yeah.
Yeah.
We do a lot of contract work for a lot of different internet companies, and I haven't seen one that wasn't started this and I just thought it wasn't going to last more than 2 years, and they're 10 years later, and now it's their main focus, because like us, we were an MSP first.
Yeah, like many people, they started it because they wanted faster internet.
Mm-hmm.
That's how I ended up with an ISP in the dial-up days.
Yeah. We built our networks mostly just because of don't want to get political, but basically gentrification, to where the middle class neighborhoods had fiber to the home, and the neighborhoods that built the middle class homes had 1.45 meg DSL, and that's all that they would get. And we cater to the Hispanic communities. So where they're trying to scale our clients' businesses and put in systems, when they're on HughesNet or Viasat or 1.45 meg DSL, and obviously that isn't going to work. So we tried brokering and being their advocates to the big telcos. And I was told many, many times, we're just not interested. Those people don't keep up with their bills. And I'm like, okay, interesting. So we built it ourselves, thinking we were just going to help our customers. But then it turned out customers have homes, and then their employees have homes. And 9 years later, we don't do MSP anymore. And we have a bigger network than I should be taking care of by myself, but here we are. And we're bringing people into the country to help support it because labor situation where it's at in the US.
Super goofy. So I guess a question I've been seeing, or I feel like is kind of important because there's a few different, like as ISPs, there's a couple different ways we're going to be experiencing cake and FQ-Codal. You know, we can use a box system that's using an x86 hardware, like Preseam or Libre, but like a lot of us are using baked in whatever the equipment is coming with. Ubiquiti, their edge routers and their Unify systems both have FQ-Codal, I believe, in them. And then Mikrotik, as I've mentioned previously, they have FQ-Codal and cake and such. What has been your experience so far, Dave, with how well those have been implemented?
Oh boy. Okay, so we did a backport of FQ-Codal, the Ubiquiti products, in 2013, and it became part of their smart queues, and they've been using it ever since, without improving it or doing anything about it to make it any better besides renaming it recently. The work was contributed by their community, which they abandoned. Not happy with how Ubiquiti has progressed with their adoption. We actually did a backport of cake for them to the ECN Pro, and it's out there. Anybody that wants to install that can do that. So my bigger kvetch is that FQ-Codal is implemented these days as well on all of Apple's products, but they forgot to put the Codal portion in. And I've been after them for several years now to have them at least implement that. There's a bug. I have a blog entry. I went and identified all the places where there was buggy implementations of this stuff. And there's another bug in one of the BSD implementations where it stops dropping at some number that's silly. And I tried to get that fixed. So those are the two biggest bugs I'm aware of, is Apple's implementation being partially implemented and that BSD bug. Aside from that, as you encountered, we had some major difficulty along the way with Mikrotik. I think as of RouterOS 7.2, they were all resolved. But I think there is still an outstanding bug in that drops and marks are not reported correctly through the UI. And that bothers me. Those are the two most important statistics to me as to how effectively it's working. So I think that covers it.
Okay, and you were mentioning Apple devices. I think you mentioned beforehand, like FQ, not the Codal part, is on billions of Apple devices, correct?
Yeah, the flow queuing portion is on billions of Apple devices, yes.
So how does Cake and FQ-Codal, how do you handle a dynamic? So, like, is there a way for either one, some way to get the input of, hey, there's a dynamic? I know we talked about auto rate ingress not working, but that was like it trying to guess what bandwidth is available. Is there some way to like feed it a like real time? Oh, hey, I got a little bit more right now, or I have a little bit less, and how does it handle that shaping changing?
Well, I said ideally with back pressure on egress, and in ingress, it's tough. I pointed you at the SQM auto rate effort, and I recommend that if you care about that, go for looking over their tools as to the kind of sensor technology they're using. They've tried a lot of cool things, leveraging NTP in particular was really neat. They also found out that an ICMP message contained timestamps, and it was almost universally implemented, and they were leveraging that. So there's also a couple other efforts going on. Apple also is behind a new transport technology concept called receiver-side LEDBAT, which means that the application itself can try to regulate its download by observing changes in latency. And that's pretty neat. Microsoft just came out with an improvement to slow start, which has been out for about 2 years. That's pretty neat. So there's a lot of ongoing research into these areas, making the internet ever less jittery and latent end to end.
Yeah, I
You can also
Going back-
mention L4S, Dave. I'm gonna
Yeah,
I'm gonna contribute to Dave's blood pressure.
Well, the L4S effort has a couple things to do with it. Comcast is actually doing trials of the L4S concept today, and that is potentially literally a game-changing technology for the cable industry. What they did is that they modified how ECN works to be a multi-bit signal. They've also modified a bunch of stuff to make that be a strict priority queue, and that's one of my. We published several reports about the L4S approach being flawed, especially for tunnels, and we did not succeed in getting it fixed. So anyway, L4S has a lot of potential for enabling cloud gaming in particular, and that is a potentially huge market. And if it takes off, I've had the patches for Cake for 5 years. I'm just not planning on implementing them until more people encounter the other realities that lie behind the upcoming L4S standard. I'm looking forward to more people experimenting with it, like everything else. And my blood pressure about it is pretty limited. Dan, I spent 6 years trying to get him to fix it, and they didn't. And it's my hope that the actual implementations will discover the need to be a bit smarter about doing congestion control and leveraging the ECN bits than they are presently planned to be. So, knock on wood. Are you fiddling around with L4S? Anybody here? Yet?
I didn't even know it existed.
Yeah. I didn't ask
it
for.
always made sense
Go ahead.
to me. Like I figured there was something like that to be able to communicate, like here's what's available and here's what the client device needs, whether that is somebody's phone, computer, game system, or whether
that's not what L4S is, though. That would be a reservation protocol. We have separate protocols for that kind of idea. But anyway, Dan you can continue, or Dan can jump in.
I was going to say, we're actually doing, we have the Hyperscene podcast here. We've got Jason from Comcast joining us on Thursday to have,
Awesome.
or tomorrow, I guess already, to have
Yeah.
a big L4S discussion. So,
well, then definitely go listen to that.
We put very limited, actually put what I feel is pretty good L4S support into the latest versions of FQ color. And you can enable it. I think it's as of Linux kernel 6.1. The fair queuing part dominates, in my opinion, but it is it's there. And I hope that more trials proceed. There's a few other improvements to Wi-Fi related to L4S, which may prove to be the most important part. And for the cable industry, again, you're pretty familiar with this already, Dan. For the cable industry, the biggest thing is L4S enables a high priority queue. Cable to date, DOCSIS 3.1 has about a 10 millisecond overall request grant latency. L4S and DOCSIS 4 enables something closer to a millisecond. So it can shave off, 9/10 of the underlying bandwidth in cable and get it very close to fiber level performance. And that's just a huge win for that kind of technology. And if they just use just that without any extra stuff, I would be happy. I have a wonderful, wonderful chat on Thursday. Again, I do appreciate all attempts to move forward on reducing internet latency overall.
All right. Well, I think we're kind of running towards the end of everyone's time, and I definitely want to respect that for everyone. Robert, did you have any other thoughts and comments that you wanted to bring up as far as implementing into ISP stuff? I know we've all been kind of bouncing and shooting away.
Yeah, I mean, something that we've come across is just the need to, as we all oversell as ISPs, that the demand has increased for really high speed plans on APs that are, maybe only 2 to 3 times higher bandwidth than those plans. So I think it's very helpful to shape at the edge. I do think it's important, like Dave was saying, we need to also do that at the CP and do coordination between those two. But I think it's helpful to queue on links between sites and to make sure that those are the congestion is limited there. It may seem like, oh, well, it's just going to be a tiny spike up to the port limit or something for what, a millisecond or a small amount of time. But that really does have a trickle down effect the further you go down your network. Especially if you're a WISP, you have a lot of, like you could be 8 layers deep in terms of like leaves off of a tree. So I think it's helpful to do that and just to keep close tabs, whether it's you're using Perseem or LibreQS, on the kind of latency, like the round trip time that your customers are experiencing, because like with changes like L4S, we're going to see a lot of competition in the space for actual like really solid low latency connectivity. So I think for WISP to compete, I think it's important to just deliver really solid latency for gamers and everyone else.
Yeah, definitely important. All right, well, Dan, or sorry, Zach, you're the one who's on the shortest time limit here. What did you have any last questions or comments or thoughts?
No, other than go use this stuff, whether it's Perseem, LibreQS, whatever, LibreQS contribute back. I've been kind of keeping the tabs on that, and there's been a lot of good contributions there. I'd like to see that keep moving forward, and yeah, that's I think what I got.
Sweet. Well, so I'll do this right now for you and then give everyone else the heads up. Zach, if someone out in the real world wants to get a hold of you out on the internet or wherever, how do they do that?
I'm on Brothers WISP Slack. I have a blog that I occasionally write on, mostly network automation type stuff. ZachBiles.net. I'm on the Matrix chat for LibreQS. I'm in a bunch of other Slacks and stuff out there. So reach out.
Yeah, you're on like just about every platform and communication technology there is, as far as I'm aware.
Yeah,
and many of them that I'm not. So yeah, reach out to him. He's super awesome, super helpful. He answers questions. I think he answered a question for me a couple weeks ago. And I was like, oh, duh, I'm an idiot. Yeah, well, Zach's the smart guy because he figured it out. Oh well, whatever. All right, well, dude, you'll be peacing out here in a few minutes. So then later, and John, what were your? Do you have more questions or thoughts on how to make this stuff, all this insanity? There's a lot of things, and I'm certain I probably have a few things left up. So I'll try and be brief too.
Probably the biggest thing that is that we're doing is implementing it in Mikrotik. So that's pretty much what it is. I still have the same thing that Rube was talking about earlier, was like the GUI isn't there with Mikrotik at all for FQCoddle or Cake, and that is definitely a frustration with that implementation. Because it's like, as soon as you create a rule in the CLI, then in the GUI it's like, oh yeah, Cake. Well, why wasn't it there already? So that is I've caught that same frustration with Mikrotik. They're like, it's there, they just don't tell you.
Yeah, and their documentation is like, I had to spend like 2 months going through like all the Dave like little comments and like figuring out, okay, this is this in Mikrotik, this is these 12 things in Mikrotik. It was, oh my gosh.
Yeah.
I actually probably need to go back through my glossary and update things as they've changed some things recently.
Yeah.
So no, yeah.
Oh, and I was just thinking, probably Zach was already working on that, if he is working with network automation as well. As far as that was one reason I was thinking of going with like LibreQS, or I was also looking at Paraquem through Chris Johnson. A way of having something to pull the information from to update and automate queues as well. To where it's like, okay, we got a storm, 60 gig is attenuating, or 80 gig or whatever. We have some 20 some mile 11 gigahertz things that still attenuate, to where that can communicate back. To where like, you don't have a gigabit anymore, you have 500 megs pipe instead of that because of network environments. To where I was wondering like if that could even be done on Mikrotik, but now they've also done their own containers and shit as well, which opens up a whole nother set of possibilities.
Yeah, very much so. Dan, Preseam is capable of doing a good portion of that, right?
Well, we don't orchestrate Mikrotik,
Mm-hmm.
that kind of stuff. No,
No.
automatically adjusting shapers for APs, yes, based on behavior and what we see for across all of the customers, like essentially combining the RF behavior for an individual AP with the profile we build across all that model deployed in a whole bunch of different places. But we don't get involved with orchestrating Mikrotiks. We do have all the topology to do that, so sometimes we flirt with it, but it's not something we do today.
Well, yeah, and definitely, yeah, orchestrating on the Mikrotik level, but you do account for, oh, hey, there's some limitation along the path that isn't just the user's bandwidth plan.
You can do backhaul shapers. Don't tend to. It hasn't been a major focus for us because it doesn't. There kind of comes a threshold where backhauls don't tend to be the problem anymore. So most people have AP problems in huge numbers, and then they might have a couple of backhauls that are problems. So we really haven't put a ton of time to backhaul shaping. It's especially at scale, it just doesn't tend to be where the problem is.
Well, and it's a lot easier to upgrade a backhaul than it is.
That's exactly it, right? Like we find a lot of customers, rather than playing with that, they'll just put in a 10 gig backhaul radio and kind of be done with it. So it is an interesting problem, and it is a problem for some people, but it's certainly been less of a focus for us than the access points.
Okay. Well, so were there any other things that you were wanting to bring up, mention, question, tell people, hey, this is a reality or a something to be prepared for?
No, I don't think so. I think we've covered a lot of ground today. Probably at a high level, it's probably opened up a lot of questions for people. I'm not sure if we opened more questions or answered questions. I don't know. Things that we've maybe learned over time is the integration stuff is always much harder than it seems. You kind of think that the problem is the shaper, and there's some great science there, and that's a hard, deep problem. But there's this really broad integration problem that touches different vendors and different equipment and different custom software and different ISPs, and it's surprising how hard that stuff is. But on the surface, you think it'd be easy, but it just is not.
Yes, I was truly surprised myself. FQ Kotl is 300 lines of beautiful, elegant code. We're at tens of thousands of lines of code coping with all the integration stuff, and I had no idea it was this difficult. And there's so many other issues like routing in the WISP market that are also intensely difficult. So my hat is
every
off.
vendor does it differently, like how you can learn the topology is different for Ubiquiti and Cambium and Tirana, and the long tail there does not does not go away, or it's just a really long tail.
So that's kind of the importance with getting all the standards ironed out to where it's at least, no matter what hardware vendor people go with, it's like, nope, these are the network standards. To where today there's some standards there, but everybody's implementation is completely different.
Yeah,
whoa.
I've kind of given up on the idea that level of standardization will ever exist in ISP equipment. Maybe I was not optimistic for a long time, but at this point, I think it's just, there's some basic things that are common, MAC addresses and Ethernet and IP. And beyond that, you kind of just got to deal with whatever vendor decides they want to do.
Yeah.
And it's unfortunate.
Soon as you get away from an RJ45 plug, it's all hell breaks loose. It's absolutely terrible, John. And you think in any universe that the manufacturers are going to standardize?
No, because they all want to say our special sauce is special. It looks like diarrhea to me, but
some of it is malicious is too strong. Some of it is that. And a lot of it is just the practical realities of coordination slows you down. So if you can just add something to your own protocol and solve a customer problem in a month versus start a multi-year IETF project to standardize it, the vendor's going to do the short-term thing. And every vendor making that decision every month is how we get to the mess we have now.
Yeah.
Yeah.
That's life. All right. Dave.
I wanted to bring this to a close because I'm well over time and have other things to do. Highly entertaining, great to be with you all today. I wanted to make 3 points in conclusion here. First one is despite all of our efforts here, the last 6 feet of the connection terminates in Wi-Fi.
Yeah.
And my group worked really hard to get FQ call algorithms into Wi-Fi. And those are in many good products today. And I hope that if you find ways of recommending or installing gear that has the right stuff in it, many of the rest of your problems will go away. I know that Robert, for example, has taken personal responsibility for making sure that the customer Wi-Fi is good and take a break at any scene. So please go forth and recommend gear that has that in it.
What would be gear that would actually have that implemented in the wireless chipset?
Almost everything derived from OpenWrt on the F9K, F10K, MT76, MT79 chipsets have it. And I'm pretty sure the new Qualcomm stuff coming out for Wi-Fi 7 will have it as well. So that's a starting point. In terms of off-the-shelf gear, there's EvenRoute and Eero. Eero was one of the first adopters of FQCODL, and it's why they took off so quickly. And the Eero 5s were the best for a while. I hear good things about the Eero 6 now. Meraki, there's a couple dozen suppliers doing it. Some Google Wi-Fi products do it, right? Others don't. It's a matter of testing to find out the stuff and reporting back is what works. I hope Tirana gets it right soon. They haven't. So that's just the part. Just make sure that all the pieces in your chain are good, and look for stuff that's running more modern code overall, because the security problems really bother me, keep me awake at night. So that's point number 1. Point number 2, as I would really love the industry to try to think a little bit further forward than fixing the next month. In my case, I've invested a lot of my personal fortune and portion of my inheritance into giving away all this technology, and has been surviving primarily on donations ever since, and the occasional small contract. It isn't just me. There's a lot of people doing stuff that can't be understood, that only one funder, NLNet, really understood such teeny little grants directed at crazy ass developers can help change the world. And if it wasn't for NLNet's contribution, none of you would have any of this technology today. Also, I have a thank you to Comcast for doing so. So please go support your local open source developer. And last but not least, keep telling people about it. I really appreciate it. It cheers me up every time I hear about you guys making another customer happy and having another less phone call, because you guys are enabling people to be able to work from home and survive in a difficult era. Thanks.
Thank you very much. I greatly appreciate that. All right. Well, Robert, what were your last lines? And then what would be your way that you would want people to reach out to you?
If you're curious about implementing QoE, definitely reach out to us. It's at libraryqos.io. Learn more about it and join us in the Matrix chat so that we can help you with integration or any sort of problems you come across as you try to test it out. Aside from that, yeah, just reach out to us on the website, and we're happy to help you get going.
Cool. All right. John, people getting a hold of you.
Easiest way is probably our phone number. But you can also email like info@geekytech.com or geek5wifi.com. We're also on Facebook. Suzette and Angela are the ones that always answer that. And if you need me, they'll get you to me because I'm always somewhere crazy weather.
Well, I know Angela can get a hold of you in the middle of emergency.
Oh yeah. Even if we're in bed, she has no problem
whacking you.
Go
Good.
fix it.
All right. Dan, how should people reach out to you?
Yeah, Presume.com has all the kind of company contact stuff. I also have a blog that I very rarely post at these days at coverfire.com. It's probably another story where that came from. But there's kind of a bit of history of network protocol geeky things there. But again, not so active these days, unfortunately.
Yeah, we're all terrible about that. And Dave, my last little thing, I noticed recently on the forum, and I've been meaning to make some posts about this. You're looking for a Linux developer to work on, is it the DSCP? You made a post a week or two ago about, it's a standard, it's looking at being taken out of the Linux stack, networking stack. Oh shoot, where was that? I have my notes.
I think you're talking about, I was trying to figure out how to edit packets to change the DSCP based on some criteria. And I actually figured that out yesterday. I should repost. So thank you for noticing. Nope, fixed all that one.
Okay. All right, fine.
Thanks for asking. Anyway, I can be reached as well. I spend a lot of time in the Libre QoS chat room. There's 120 people in there. It's been a great therapy site for us all. And I'm also reachable via email primarily, dave.taht@gmail.com.
There we go. You can reach out to me. I'm Tommy at lostcreek.tech or thebrotherswisp@gmail.com. Reach out, say hi. The Brothers Wisp, huge shout out to all of our patrons who you guys are like the reason this exists and are the reason I'm able to do this. Catch you all later.
Start searching, shooting up the web in neighborhoods, net surfing. We got horrible jokes, we're loud and annoying, but we're informative facts, we're not disappointing. Just give us a listen, cause fun is the mission. I'm telling you, you don't know what you are missing. Ideas and some good comedy given. If you missed the show already, don't worry, you're forgiven.